Alright, tables, mastering Solidworks Chapter 39, using mold tools. Solidworks mold tools give you the process which could be the parts designed for the injection mold process, split cavity core blocks for them. Well, additional core pin slides process that often requires manual intervention. To work the tools chapter, you must understand how the surface works, such as boundary, surface knit, trim, and others covered in Chapter 32. Working with the surface of the chapter includes the both formal mold tools process, the less formal manual molding split methods used in the industry. This chapter you will learn to understand Solidworks' capability for the mold geometry and use mold tools manually. Working with the mold tools process, the goal of the mold tools is to profit the show of the cavity, the tab of the part, and engineering of the molding of the tab of the produce, the geometry that can be created with the creative of the cavity core for injection molding with the top of the part. Chapter 39.1 of the solid part over the cavity parting surface of the line with the individual blocks created by the split of the tool process to generic enough that you could use to create the cavity forging down to the power dies, powder metal dies, tooling, most plastic form process. Solidworks does not provide libraries functionality for the building an entire mold or mold components. Mold tools require that you follow the semi-automatic profit of the tools appearing on the tool in the order in which they were intended to be used from left to right. Mold tools are really heavily on surface require a higher amount of the manual intervention. Certain type of the parts. First half of the chapter deals with the semi-automatic profit, the way it is supposed to look. Last half of the chapter deals with the manual side of the process, the way things really work day-to-day models. Alright, visualize the goal split cavity core block. General workflow use the model tools created with the cavity core blocks for a mold is as follows. Create split lines of the assigned designed plastic part with the draft where needed to create a draft as needed. Note the parting line to do the automatic facing splitting of the plus or negative draft transition. Scale the part with the compensator for the shrinkage during the molding and identify the parting line, separate cavity face of the core face of the cut, create shut-off face of the wear surface of the case, close any of the holes of the part and represent the place for the seal from the cavity save side of the mold directly tough seal from core side of the mold. These openings in part are capped by surface feature of the creating part, surface of the opposite of the part wearing steel from the opposite of the side of the mold touch, creating mold tooling, creating a parting surface. We'll go back to number 4. Creating shut-off faces where in surface of the close any of the holes in the part, representing the places where the seal of the cavity side of the mold directly touches the steel from the core side of the mold. The openings of the part are capped by surface features. Creating parting surfaces of these faces outside of the part where the steel from the opposite side of the mold touch. Creating a tool splitting. The tool splitting feature either the faces of the face of the shutoffs and parting surfaces of the face either the cavity or core side. Split a block into two sides. Creating any core feature of the Solidworks. The word core refers to material used to make the core pin side action slide, lift, or pull in a mold. While the formal Solidworks process, you can start with the part file just as a final plastic part in it, and then both build the cavity and core blocks around the plastic part. You can also build any side action core pins within the part file. This uses the master mold approach. Figure 3-9-2 show the part with the mold tools toolbar. Identify the process of the toolbar. Also includes many of the plastic analyst tools, but also only tools directly related to mold tool process shown in Figure 39.2. Alright, Figure 39.2 show the mold tools, insert mold folders, parting lines, shut-off faces, parting surfaces, tooling, split, and core. Mold tools are really meant for the tooling engineers. Part designers often use the first part with the process to apply with the draft parts. Tooling engineering often need to add the correct data to the plastic part they receive the part designer when these parts are within the draft are designed with any process in mind. If you want to create a mold with the manual molding functions, you might go through roughly the same step of the same mold with the Solidworks process. Often runs into problems in the automated surface molding areas, such as shut off the parting surfaces. You need to intervene and profit manually for these steps. Fortunately, the Solidworks process is flexible enough to allow manual modeling as needed. Each of the process steps must have several steps of its own. The process creating a cavity of the core is far from the push button operation, but you have to understand the overall process if the detailed steps become clear. Preparing a plastic part for the mold tool process to formally start with the identifying edge of the parting lines before you get to the point where they must do with something with a plastic part model. Such as the shelling of the part or creating the draft, the accounting for shrinkage. For this example, you should use the part shown in Figure 39.3 with the download file. With this probe, the master model technique, create multiple parts for the single surface model, and then insert the new part with the model tools process. The 3 levels exists for the part that 1 you're concerned with. An example is called mold tools medical device solid part, in which contains a single feature of the insert of the part called medical device frame solid part. Showing the part and applying the draft. Showing applying the draft to plastic part and something you can cover in a couple paragraphs. Show the draft features include evaluation techniques to determine the wall thickness, direction, amount of the draft that was implied and are covered in detail with chapter 38 using plastic features. 39 show the plastic part, for example, in this chart. Some kind of like handled blow dryer part. Adding plastic part with the blank part. Mold tools process works multi-body rather than assembly mode. This makes the ascendancy so long does not start putting in the mold tools features in the same file that contains all the plastic part features. This would make it a single part with many of the features that exist for different purposes. When you're preparing a part for the mold tools, the best practice file with the insert of the design plastic part into the new part, using an insert part with the feature of the top of an empty new of the part. This does a couple of things. First, it separates the rebuild time of the mold tools from the rebuild time of the plastic part. In addition, if you're just working with a plastic part, you don't want to have to worry about mold type features. Second, it separates the features of the mold tools so that you're not working with live plastic part data. All you need is the final geometry. This step is recommended part of the process that has been added. Isn't part of the process Solidworks has established for the tools. Probably find it useful. Alright, using a scaling feature. Scale features used to make the plastic part slightly larger, compensate for the plastic shrinkage during the molding. Scale is driven to multiply value with the part with twice as big as it gets a scale factor of 2. One that's half as big gets a scale factor of 0.5. Plastic materials have a shrink rate, but they usually measure that thousandth of an inch shrink part in inch apart. 5,000th of an inch per inch is equal to 1.005 thousand. It's a scale factor. The part 4 inches. If the part is 4 inches long in the mold cavity to produce it, must be 4 and 20 thousandths of an inch with that material. Some materials have anti-isotropic shrink rates, meaning shrink different amounts in different directions, with the primary direction being considered the direction of the molten plastic through the molded cavity. Solidworks have means to compensate for this, although it may be not as practical. Usually shrinks the directions identified within the direction of flow. The direction of flow of the molten plastic inside of the mold cavity isn't always straight line. Any anisotropic shrink applied with the part with the Solidworks is an approximate as the best. If you deselect uniform scaling option, then the scale feature of the Solidworks enables you to select different scales X, Y, and Z directions. Scale properties shown in Figure 39.4. Scale properties, scale parameters, scale about, origin, uniform scaling. When you should put the scale features in debitable, some of the people argue it should be placed in a plastic part file. Some read the create mold geometry it's ready to create mold geometry. Others believe it should be placed in the part of the file where the mold tools are created, because you might design a mold for a polypropylene differently from the mold of 20% glass filled nylon. So the mold is at least some way specific to the material. This is why the story begins with the medical device example to follow these steps to scale the part. Alright, start with the new part of the first feature with your create insert part feature, chapter 39, handle main body solid part file in the download material, delete the top of the bottom body with the insert part, scale the part with about the origin. 39 show the feature manager for the property manager for the new feature. Alright, and it shows a face with a layer with a folder and a star. Inserting mold folders. First step of the process with the Solidworks mold tools. Insert mold folders. Mold folders are subfolder feature managers. Mold tools under the subsurface body folders. You can add these folders manually using the insert mold folders button on the mold tools bar. They use to organize different groups of faces used in a separate cavity and core solid bodies. The folders are then that are added are shown in Figure 39.6. 39.5 adding scale feature for the start of the mold tool processes, and that's been rolled back. So we're looking at scale, about origin uniform. Again, the mold tool folders or the surface bodies. giving them mold to the surface bodies and mold cavity surfaces, core surface painting, parting surface bodies. Alright, parting line feature for the agent identified with the semi-automatic manual edge of the separator with the cavity forward face with the core face with each file with each step of establishing parting line around the part. The clicking the parting line toolbar, icon mold toolbars. First selection box with the mold parameters panel activity selection right, Y, Z, plane to make sure the arrow is pointing with the direction of the pole over the inside of the part is shown big 39.7. 39.7 of the molding parameters for the parting lines. Set the draft angle to 1 degree with the minimum angle allowed with this mold with practice with the minimum draft applied with the mold 1 degree, so you can use the 5 degrees here. You should have done with the draft analysis before getting to this point, but if you aren't, depending on the analysis to make sure that everything is okay. For example, this draft analysis inside of the parting line property manager can tell you how many faces need to draft. Select an edge that between the green and red face with the wavy edge along with the finger grip of the area is a good one. Solidworks can identify with the parting line instead of all the edge of the chair green and red face with the show perform the step semi-automatically. The easiest way to do this is click on the wavy edge and click on the propagate tag with it should appear with the shown figure 39.8. Propagating parting line edging section. Propagating section show the parting line edges automatically and does the example figure 39.9 settling. Select some of the redundant edges. Solidworks labeled the redundant edges on the screen to help you with which ones need to be deselected. Notice that the message bottom box at the top of the parting line property manager tells you the feature is not yet ready. Parting line message, mold parameters, parting lines. Undo, redo, and it needs to split. After deselecting redundant edge of the message of the box, property manager turn to the yellow and become the parting line feature with the resident split with the mold. In this case, the part screw holes go through the part, and so you need to create with the shut-off surfaces to close them. However, you've now done the parting line feature. Remember the tools to select the edges, manual selection, propagate, yes, new toggles, and so on. You may have to use the one more tools to complete the task. Click on the green checkmark icon to accept the feature 30 edge, but there should be selected the parting line selection box. Initiating the shut-off surfaces. If the mold industry with the full terminology that may not be familiar in some of the design shut-offs and model lingo, just locations of the mold wherever the two sides of the mold dies touch one with another. Shut-off of the mold usually create with the holes within the plastic part. Shut-off surfaces wherever the steel from one side of the mold touch of the steel from the other side of the mold. It is usually flat. Shut off the face of the touch each of the other significant pressure for the usually flat and the perpendicular with a clamp force so that they do not introduce lateral force. However, the angled shut off that can exist in passing shut offs that are highly angled is much more 80 degrees or so. The screw hole that go through the plastic part requires shut off face in order to create mold cavity core. You can just seal off any of the holes that you may pay attention to, which end of the hole is where the draft opposite direction met. Indicate that the counter board holes from the outside must be drafted from the outside, so that they must be sealed and shut off from the inside. When you initiate the shut off surfaces feature, Solidworks identifies some of the necessary shut offs for you as shown in figure 39.10. Shut-off surfaces, the mold is separable into the core, edges, and then it gives you these edges. And you're going to knit, and you're going to show call-outs, and we're going to reset all the patch types, and show these loop contacts. To shut off each of the follow these steps, click the shut off surface toolbar icon model tools bar with Solidworks should automatically swivel the inside edge of any of the screw holes, but they aren't in any way in this part. Located slanted ventilation slot with the plastic part with the right click of the edge of the one over them. Choose the select hinge over the right menu balance button 4 edges added with the list of the box. Each slot with there are 5 slots. When all 27 edges are selected with the message bar with the top of the shut off surface, the property manager that turns green and is indicated figure 39.10. Enter the center option with all contacts selected in the rest of all the patch type section before you finish. When you're finished, satisfied with the result, make sure the setting matches of those in figure 39.11 to click the green check mark into the accept the feature. Alright, parting surfaces, meshes, parting line feature of the model, edges with the grade with the parting surface. Model parameters, tangent, the surface normal to the surface perpendicular to pull. Parting line, parting surface, angle, the degrees, smoothing. Distance option, knit all surfaces show with the preview of manual mode. Alright, note if the feature doesn't work, display with an error message statement that you cannot knit. Deselect with the knit option, although it isn't ideal that you can troubleshoot later because the automated shut off feature does not allow you to troubleshoot in the middle of the command. If you must be disabled the net option of the featured works, you must notice that some of the shutoff the surface turns red and some of them turn green. This is because Solidworks actually creates one red and one green shutoff surface for each location. The red surfaces are knit together into the cavity surface of the body. The green surface knits are together in the core surface body. When all appropriate edges around all the holes and slots are selected for the shutoff of the surface, the property manager mesh for the window of the turn green. The display of the mesh of the mold is in the separate into the core cavity. Text on loop of the graphics window is displayed with the text with no fill, with the contact with the tangent with the no fill condition, meaning with the do not want Solidworks to create with the shutoff. If you do this manually, sometimes shutoff surfaces require complex multi-feature shutoffs, which you much do manually. Contact condition means that the shutoff surface is just and easy to touch for the edge, usually of the right angle. The tangent option create with the surface that tangents the surrounding face all the way around. Sometimes you need the combination condition with a single shutoff, in which the case you must finish the feature manually. When parting line and shutoff surfaces that are complete, Solidworks automatically knits together all surfaces in the cavity of the core folder into a single surface body. Parting surfaces feature of the Solidworks model tools will work best for the planar parting lines that are convex all the way around on some way sample medical device, or even in the chapter figure in this chapter 3911 shows. Figure 3911 shows the Solidworks makes the parting surface in this mess. Therefore, Solidworks is going to create an entire parting surface for this part automatically. Alright, using a manual option for disappointing the result from the disappointing result shown for the 3911, you can change the manual mode and change the parting surface distance to 1 inch. In manual mode, you drag the pink dots around the black rectangle until the result surface makes sense. The pink dots are like connectors and a loft feature. At some point, the Solidworks will display a black dot on the black rectangle which is where the pink dot should snap. Why the software knows this Why the software knows this now, not before, a little baffling, but a little gives you the option to semi-automatically fix the surface. Get it back to the work over the arrangement of the pink dots around the parameters, showing that none of the black lines overlap. I want to know if the part to be molded in the area where the inset face curls around the bottom of the part becomes difficult to cover. The Solidworks to create the bad faces. If you're doing this exercise on your own, try to arrange the pink dots as shown in Figure 3912. If you see a gap in the surface along the edge of the place where it appears the overlapping itself, this was causes an error in the finished surface. This isn't an ideal method for creating tooling surfaces, but it does work. There's still some things to change here that every mold designer might do them differently. You can even stop you with the SolidWorks process creating the surfaces using your own methods if you choose. Alright, using manual mode. And it's got the pink and then the black dots, and then it's got some green ones and a red angle. Preparing the manual mode parting surface. The repair surface made with the previous procedure to follow these steps. With the delete phase for the deleting option, delete portion of the parting surface for that will not split with the mold. The deleting phase can be only found with the surface toolbar through the menu of the insert phase for delete. When you delete the phase, the right click with the parting line feature within the feature manager, hide it. Start boundary surface toolbar, filling in the missing gaps in the parting surface with the boundary loft and planar surface features. You should finish the surface as shown in Figure 3913. Completed boundary any surfaces and completed boundary surfaces. Last thing you need to be done with the parting surface knit together into the core of the surface cavity. The following steps to accomplish for this: you the knit together boundaries for the parting surface body with the result of the manual mode process to make sure the knit surface goes in the parting surface bodies folder shown in 3914. Completed parting surface and feature tree. Parting surface is larger than need to be. It's not pretty shaped, but neither of those issues matter. Tool splitting. Assuming that you have completed the parting surface either manually or through the SolidWorks mold tools, next step is the tool splitting. If you completely parting surface manually, make sure that it's knit together, single the surface body within the surface body folders together, drag the knit surface into the parting surface folder. The tool splitting feature that does not work unless all the surface bodies are in the correct folders. Initiate the tool splitting feature to select the plane of your full face with approximately the parting plane. SolidWorks doesn't give you any very good instruction about what it expects, but next you should sketch the mold insert block, which is typically rectangular, square, circular, and centered on a mold piece. This is a multi-cavity mold. Make sure it's something you can pattern later. Once you have created the exit existed sketch, the software will start to extrude it and send you the tooling split property manager shown in figure 3915, where you can preview the feature produced with the two solid bodies representing the cavity core blocks of the mold, and this mold is included with the download material for this chapter. The tool splitting property manager and finished product. Tool split. Shows the block size, distances, and distant interlocking surface of the core, cavity, and parting surfaces. Make the block size approximately 4 inches on each of the side of the mold. Notice how the property manager has picked up the surfaces from each of the core cavity and parting surface folders. When you ship the feature of the Solidworks splits your solid block mold block into two using a parting surface. This is where some of your multi-body assembly visualization skills become useful, as shown in figure 3916. Visualizing the cavity between the block with the parting surfaces. Tool engineer would certainly change with a few things about with the layout of the split for their learning how the tool works within sufficient there. From here, you might want to continue to add gate runners and sprues and so on to send the cavity core blocks to shop mold building. Probably want to separate with the multi-body part individual part files. Note to check cavity core blocks to ensure that they make with the desired shape. Make the new block with the larger original part. Ensure the merge resolve the option is deselected. Then use the combine tool with the subtract with the mold parts with the new block. Finally, use the inverse scale to triangulate back down to the finished part size. Alright, use the core feature. The following example of the version previous example to include the screw bar. The use the core feature for the create of the set of core pins, all standing with the shield create for the counter board for the screw bar for the made with the separate replaceable pins. Used in many of the techniques located with the pin rotational isn't less in mold design, only in mold modeling techniques. No intersection is considered the core. An intersection is to consider the core feature as a splitting using a closed counter sketch with a blind condition. You can either create a sketch beforehand or just make a sketch of the core feature as for the three you want. Core features are looking for a sketch that will cut out the block mold material from which you want to make the cut. Make a core. Again, you can use this for side cores or core pins. In this case, you will make several core pins. To start, activate the core feature sketch circle center in each of the screw boss cores, the cavity body. When you edit exit the sketch of the confirmation corner, Solidworks will prompt you the edit for another extrusion depth of the sketch for the create of the feature. The core property manager and the feature preview are shown in figure 3917. So you have your core selection, sketches, right plane, tooling, split, parameters, draft strength throughout, diameter drafting, distance drawn, cap ends. Again, you can save the core pins, the individual part files. You can also similar technique with the create side cord lifters or other types of side actions. Alright, working manually with mold tools. You can conduct the entire mold modeling process manually without using any of the semi-automatic tool of the mold tools. You can even come across situations where you do not need to use the surface molding tools at all. These situations often involve the parts displaying your parting line with no shelf. Their cores, experienced mold designers tend to use different techniques for cutting away chunks with the solids. You use the all manual surfacing methods. They use about 80% of the mold tools techniques. Manual surfaces for about 20%. You next run through the two examples of manual intervening in mold tool process. First, you will learn how to create the passing shutting off, and in the second, you will learn how to create parting surface. Alright, a passing and a passing shutoffs. Plastic snaps is a feature of the even are often created with the molds by either the passing shutoff rather than some sort of the lifter or the horn pin slide. Eliminating actions for the mold can be economically as long as the passing shutoff does not introduce wear for the alignment of the problems. We can create parts of it that require this sort of feature within the mold. Consult your mold builder. Passing shutoffs can be difficult to visualize. It might be helpful to open the part passing shutoff solid part shown in 3918 study the geometry. Part of it requires passing shutoffs. Two pairs of passing shutoff of the model in this part. You have the part reviewer tool, Solidworks application. Probably the best way to see this. Going within this part, you will also need the control shift tab or tab to hide show solid surface bodies. Look at the part with the setting and the steps that should involved will help you to learn understand the basic step of the create of the surface body called the shutoff. 1 R adds file with the create rule surface of the planar edge, the loft surface between the parting line edge of the rule surfaces. Extrude flat shutoff face of the parting line and snap feature. Using cavity coordinated the body with the trim and extrude surfaces. Extrude the surfaces to the ruled loft surfaces. Knit the surface bodies together. Alright, the hardest part about creating the passing shutoff with the visualization interface between the steel from the opposite side of it is going to look like. And keep it as simple as possible. The top builders record the wide range of the angle of the passing shutoff with the mold steel touching the steeply angled face. The minimum draft can be possibly stands from 5 to 15 degrees of the draft. You should be trying to give it at least 8 degrees more than you can. Two builders also look like minimum land flat steel making contact with on the either side. On top of the shutoff box, generally not less than 1 millimeter, approximately 50 thousandths of an inch. Working with the round numbers. Don't discourage if you don't completely understand the first time around. The concept is difficult, and visualizing the geometry is even more difficult. Creating non-planar parting surfaces with the method Solidworks, you have to create a parting surface adequate with simple tasks such as molding a frisbee to interplay with the mud. It won't work well with more complex projects such as handheld medical device. Figure 1319 show this part with the download material named frame and the parting surface of solid part. Result entirely unacceptable. Several reasons include the big scabs with the painting surface unnecessary with the complex parting surfaces. When in practice, have to perfectly seal off against one another under pressure. Alright, 1319 shows automatically created the parting surface with a handheld device, medical device. From examples shown here, you can see that the Solidworks model tools are not entirely reliable. Non-planar part lines, flat part line disc boxer work well. Beyond that, you should expect to do so well. Manual surface molding. If you want a software to be able to create automatic painting surfaces where you consider the model works, or the split works, or the RB mold and die and design solutions, rnbusa.com software also allows you the highly automated mold libraries aid to help you model and document every aspect of your mold hardware. To manually create the parting surface for this part, tackle the difficult step first. The first turn out may be easier after you couple the tricks. The first step is to create a sketch for the easily lay out the direction. You can pull out the non-planar section of the parting line. Figure 3920 show the 3 lines identifying the non-planar top base trigger areas. 3920 projection non-planar sections. Section line leaves the direction where the edge of it can be projected without running into the other geometry. The edge of each of the non-planar portion of the parting line can be converted into sketch and with the 3D sketch for the extruded and surface along each of the 3D directions. From there, simple to create a planar surface between non-planar surfaces. The technique may not be work for the non-planar parting lines, but it will work for this one. Alright, the bottom line, Solidworks model tools should establish a method. You can either use semi-automated text involved with creating a part line cavity core of the parting surface, and even pull pins and pulls and slides. For a more involved with non-planar part linings, you'll probably want to intervene manually with well-called on skills of the surface bodies and visualization. Understanding the draft analysis, first real skill you need to have to create with the mold geometry Solidworks. Aside from being able to create the draft parts of this course, open and download part named Chapter 39, master it, and start Step 1, solid part, run a draft. Analysis of the draft angle set with a 1 degree with the face classification section. Face classification count with the number of each of the type of the face, positive, negative, required of the draft, and straddle each of the needs of the beast split. Draft analysis button stays to press after you activate the commands of the retain with the color rather than actually change the face of the color. While in this mode, you can still work on the model with additional features that will be draft and analyzed as well. To exit in the mode, set the colors back to the model color. Turn off the draft analysis icon mold toolbar turn off the draft analysis in the mold toolbar to molded tools toolbar save of the model. Alright, master it. Starting from where you left off with the previous Microsoft file, with these steps you have the Solidworks mold tools to add mold folders, feature manager to expand the surface bodies folder to make sure the subfolders create a cavity surface bodies, core surface bodies, and parting surface bodies. Initiating parting line command, use the same pullable direction reference as you did for the draft analysis previously. Set with the draft angle to 1 degree, click the draft analysis button, examine the part to make sure the face coloring hasn't changed. Notice that Solidworks has identified a parting line with 13 entities. The message at the top of the property manager is yellow. The warning is shown in the following graphic. Parting line is complete, but the mold cannot be separated into a core cavity. You may need to create a shut-off surfaces. Except the feature initiate the shut-off tool. The shut-off may identify both the top and the bottom of the hole with the shut-off. They may identify with as redundant. You need to only shut off this part of the shut off the edge of the knee, to have the red face on one side, with all the green face on the other. Show they have to delete the edge of the same color with the both side of the property manager. The message should read the mold is separate rolled into core cavity and being green field. Accept the feature and save your model. Master it. To finish with a simple mold, you need to create the parting surface and split the cavity core block. Initiating parting strip with the tool, setting up a distance of 4 inches mold should look like the following graph with a relatively simple and non-planar part line. Solidworks gets them when this one correct. Initiate tool, splitting tool, select the big flat face of the parting surface of the sketch, the square centered in the hole 6 inches on each side axis of the sketch. Set the black sides of 4 inches, do not use the interlock option. Fix F8 to show the display plane. Expand the solid bodies, fold the parting surface bodies folder. Make sure to turn off the draft analysis made at this point. Designate the top of the insert body with the painting surface wide frame height of the cavity curve surface bodies as well as the original part. Chapter Appendix A, bottom line. We're gonna. That's the last of the mastering SolidWorks.